Hello, this is Mrs. Ward, and I'm going to go over the notes from section 9.5, the binomial theorem. You're going to use the binomial theorem to calculate binomial coefficients. You're going to use Pascal's triangle to calculate binomial coefficients. And then you're going to use the binomial coefficients to write a binomial expansion. Binomial theorem is probably one of the most useful tools that we have in order to help us expand binomials, which will come really handy later on in life. So if I have the quantity of x plus y raised to the 0 power, that's equal to 1. If I have the quantity of x plus 1 raised to the first power, that's equal to x plus y. Notice that the x plus y is a binomial. By binomial, that means that there are two terms. So here I'm raising it to the first power, the second power, the third power, and the fourth power. I just went down and raised them to the different powers, and then I did the expansion. And I'm hoping you recognize the pattern. So I'm going to have you pause the video for a second and see if you recognize the pattern. Okay, one of the patterns you should have recognized is that if I have my first term is going to, the power of my first term is going to match the power that the binomial is raised to. So in other words, the first term is always going to be x, like if it's x plus y squared, the first term is going to be x squared. The last term is going to be the second term, and it's also going to be raised to that same power. So you'll see x plus y to the third power. This last term is y to the third, y to the fourth, y to the fifth. Another thing that you should have noticed is that if I have x plus y to the first power, I have 1, 2 terms. If I have x plus y to the second power, I have 1, 2, 3 terms. If it's raised to the third power, I have 1, 2, 3, 4 terms. So the number of terms you have is one more than the exponent. So like when I raised this to 0 power, I just had one term. So when I go down here to do this x to the 6, there's some things that I can write. Since it's raised to 6, I realize that I am going to have 7 terms. I know based on what we talked about before that my first term is going to be x to the 6. Whoopsie, that's really thick. And my last term, way back here, is going to be y to the 6. I know that I'm going to have 7 terms. So then I start looking at these coefficients. And here, if I just write the coefficients, I have 1. Just writing coefficients, I have 1 and 1. And yes, I'm purposely putting them in this triangle format. So I'm going to have 1, 2, 1. I got that from 1, 2, 1. So it should make sense that here, when I'm raising it to the fourth power, the second term begins with a 4. So I'm going to have 6x. Notice that the powers go down of x go down by 1. So 5, 4, 3, 2, 1. So I'm going to have x to the 5th. Then I'm going to have some type of x to the 4th, some type of x to the 3rd, some type of x squared, some type of x. And then my last term is just going to be that y to the 6th by itself. Then notice that the y's go up. So this will be y squared, y to the 3rd, y to the 4th, y to the 5th, and then this is y to the 6th. At any point when I add the exponents, like when I add 2 plus 2, that's equal to 4. When I add 3 plus 2, that's equal to 5. That happens every single term. Then to find the coefficients, and that's what the binomial is talking about, is to find the coefficients. This one appears, I have 6, and then I know that this one is going to be a 6. And this is really, really messy, and I apologize. Let me rewrite. 6x to the 5th y, and then back here I'm going to have 6x y to the 5th plus y to the 6th. Then if I look here, if I add 3 plus 3, I get 6. So if I add 4 plus 6, I get 10. So if I add 5 plus 10, I should have a 15 here. And then 10 plus 10 would be 20, and you have no idea how I'm getting these. And that would be my expansion. So let's go on how I do this. So I'm going to have the expansion, and here's the expansion. This here tells me that the power n, the x goes n, then n minus 1, all the way down to there being no x, and then the y counts up. So this is technically y to the 0, which would be 1, y to the first, y to the second, all the way up to n. Notice that the exponents, when I add these exponents, and this is understood to be 1, and this, and when I add them, they will always equal n. This is a combination, which you should have learned in statistics. To do a combination, you take the number. So I'm going to do n, choose r. So n factorial over n minus r factorial. So let's practice doing the combinations first. So the combination of 9 choose 2 would be 9 factorial over 2 factorial. Then take 9 minus 2 and get 7 factorial. And that's exactly what I have here. I just sort of did it in a different order. I switched those two. Don't know why, but I do. So when I do this, I'm going to have 9 times 8 times 7 factorial. You should recognize this from before. 2 times 1 times 7 factorial. Now the 7 factorials will simplify, and then I can simplify the 8 and the 2, and my final answer is 36. So when I do this 11, 4, that's a combination 11 choose 4. So I'm going to do 11 factorial over 4 factorial. So 4 factorial, and then 11 minus 4 is 7 factorial. So I'm doing 11 times 10 times 9 times 8 times 7 factorial, and then this is 4 times 3 times 2 times 1 times 7 factorial. This should look very familiar from the last section. I am going to simplify some of things. So 2 times 4 is 8, 3, so that'll be 330. I think if I did my mental math right. And this one is a combination 8 choose 0. So 8 factorial over 0 factorial, and then 8 minus 0, which is 8 factorial. Well, these 8s will simplify. And remember, 0 factorial, just a reminder, 0 factorial is equal to 1. So this will be 1 over 1, or just 1. So that's how I find my coefficients. So remember, the coefficients are going to go out in front of the term. And so let's see this. So if I want to find binomial coefficient, you're going to do the same thing you did before. This is going to be 10 factorial over 3 factorial, and then 10 minus 3 is 7 factorial. So this is 10 times 9, let's see, times 8 times 7 factorial, over 3 times 2 times 7 factorial. The 7 factorials will simplify. The 2 and the 8, that'll be 4. The 3 and the 9, that'll be 3. So 120. When I go to do this one, the combination 10 choose 7, I'm going to do 10 factorial over 7 factorial, and then 10 minus 7 is 3 factorial. That's going to be the exact same work, the same thing. The only thing is if these two switch orders, my answer is still going to be 120. So what you're going to notice when I go back all the way back here, when I look at this, if I have a 3 here, I have a 3 here. See how I have 4 here and 4 here? That's why, because the combinations are going to match each other. So sometimes you have this oddball guy in the middle, but they kind of match, and that's why we're going to eventually make a triangle. So let's, I had another one here that I wanted to do. So if this is a combination 11 factorial, choose 1, 11 minus 1 is 10. So this will be 11 times 10 factorial over 1 factorial, which is just 1 times 10 factorial. These will simplify, and I'll just be 11. Here, if I do 11 factorial, 10 factorial, 11 minus 10 is 1, exact same work, so I'm still going to get 11. So it's kind of like symmetrical, I guess, is the best way to do it. So Pascal's triangle is by far my favorite way to do this. And so instead of me doing the combinations, especially if I'm only raising something to like the 5th or the 6th power, I'm going to choose to make Pascal's triangle instead. Instead of doing all those combinations, I'm just going to simply follow the pattern of Pascal's triangle. So I start with a 1, and then I do a 1 and a 1, and then 1, 2, 1. And then the pattern is I always start with a 1, add these two, so 1 plus 2 is 3. Add 2 plus 1, I get 3. And always end with a 1. So I start with a 1, end with a 1, add the two terms above it to figure out the next. So here I'm going to start with a 1, add 1 plus 3 and get 4. 3 plus 3 and get 6. 3 plus 1 and get 4, and then end with a 1. When I go to do the next line, I'm going to start with a 1. 1 plus 4 is 5. 4 plus 5 is 10, or 6 is 10. 10, 5, and 1. Let's do a couple more. So I'm going to start with 1, 6, 15, 20, 15, 6, and 1. Notice that I add the 10 plus 10 to get 20, the 5 plus 10 to get 15. Okay, one more and then we'll call it quits. So I have 1, 7, 21, 35, 35, 21, 7, and 1. So this, just to refresh, this line right here, this line right here is going to be x plus y raised to the 0 power. This line right here, crayon is never a good idea. This line right here is going to be x plus y to the first. So the number of row that you're on is technically one less than the, or one more than the power. So here I'm like the third row down, that my binomial is going to be x plus y squared. So you can see how that will just keep on cycling through here, and I can, so if I have x plus y to the third, these are going to be my coefficients. And if I go all the way back to that very first slide, when I had x plus y to the third, you'll notice that I had the 1, 3, 3, 1. And that's exactly what I get here. The 1, 1, 3, 3, 1. When I did the 6, I had 1, 6, 15, 20, 15, 6. And that's how I got it. Is I'm using Pascal's triangle. So if you use the fifth row of Pascal's triangle to do the binomial coefficients, notice that this is 6 because that is my fifth row. So I'm doing 6, choose 0. So when I go back to Pascal's triangle, this is going to be the row that I look at. And when I do that, I'm going to have that 1, 6, 15, 20, 15, 6, 1. So I don't have to do all the combinations if I did Pascal's triangle. This second number here should match this number here. See how that's a 6 everywhere. So this is a first term, second term, third term, fourth term, fifth term, sixth term, seventh term. I have 7 terms. Remember, I have one more term than the number, whatever power I'm raising it to. So when I go to do this, if I want to write the expansion of x plus 1 to the 4th, this is what I call a baby one, I am going to make boxes, I guess is the best way to do it. And the first thing I'm going to do is here's my x and here's my 1. And then I'm going to write my coefficients. Well, if I do my coefficients real quickly off to the side somewhere, I would write Pascal's triangle, and I'm going to get good at doing this. So this is the row that I'm looking at. I'm raising this to the 4th power. I have 1, 2, 3, 4, 5 terms. I do. And I'm just going to copy those coefficients down. So 1, 4, 6, 4, and 1. And that finishes off my box. Then remember when we were talking about this before, this x starts being raised to the 4th power, then the 3rd power, 2nd power, 1st power, and then the 0 power, which would just be 1. What happens with the 1 is the 1 starts being raised to the 0 power, then the 1st power, then the 2nd power, then the 3rd power, and then finally the last one, that 4th power, should match that exponent. When I go to write my expansion, I am going to multiply down. So I'm going to take this 1 times x to the 4th times 1, and I'm just going to get x to the 4th. Multiplying down here, I'm going to take 4 times x to the 3rd times 1, and that's going to be plus 4x to the 3rd. Multiplying down again, I'm going to take 6 times x squared times 1 squared. Well, I probably should have written that, but 1 squared is 1. And when I multiply all that, I'm going to get plus 6x squared. Keeping that pattern, 1 to the 3rd is 1, so I'm going to get 4x. 1 to the 4th is also 1, so I'm going to get 1. So if I take x plus 1 and raise it to the 4th power, this is my expansion. So a lot easier than taking x plus 1 times x plus 1 times x plus 1 times x plus 1 and foiling. I'm just going to use the binomial theorem to expand it. Let's do another one where we have a little bit more action. So this one, I'm going to do x minus 2 to the 5th. So I'm going to make that table. Here's x, and then I'm going to make this negative 2 because the binomial theorem actually goes for plus y. So I'm going to think of this as plus and negative 2. Then I'm going to find my coefficients. My coefficients are going to be adding one more row to this triangle. So I'm going to add one more row, and this will be 1, 5, whoopsie, 10, 10, 5, and 1. Notice 1, 2, 3, 4, 5, 6 terms. That makes sense because I have one more term than the power that I'm raising it to. So when I do this, I'm going to write my coefficients, which I said were 1, 5, 10, 10, 5, and 1. Those are my coefficients. Now I'm going to start this x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and this is technically x to 0, which is 1. Then I'm going to do negative 2 to the 0, which is 1, negative 2 to the 1st, which is negative 2, negative 2 squared, which is positive 4, negative 2 to the 3rd, which is negative 8, negative 2 to the 4th, which is positive 16, and then negative 2 to the 5th, which is negative 32. Now I'm going to multiply. Do not forget the coefficients. That's why I'm making this video. So I'm going to do this here, and I'm just going to color code. Can I color code? I can color code. Let's color code all at once. So when I multiply, I am going to have 1 times x to the 5th times 1, so that's going to be x to the 5th, plus, and then we have 5 times x to the 4th times negative 2, so I'm going to change that plus to minus, because I'm going to take negative 2 times 5, which is negative 10 x to the 4th. Now I'm going to multiply 10 times 4 and get 40, so this will be plus 40 x to the 3rd. Then 10 times negative 8, so this will be negative 80 x squared. And 5 times 16, which will be a positive 80 x, and just x to the 1st, so I could write the first if I want. And then we have 1 times negative 32, so minus 32. So this x plus, oh, actually it was x minus 2. X minus 2 raised to the 5th power. This is the expansion of that. So that's not bad. That's not bad at all, as long as you do the pattern. All right, so here I'm going to do this 3x plus y. I'm going to think of this 3x plus the negative y. So here's 3x. Here's my negative y. I'm making my box. I'm going to do my coefficients of something raised to the 4th power. And here I can do that real quick. Just do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Everyone's with me. 1, 4, 6, 4, 1. So this will be 1, 4, 6, 4, and 1. Now I'm going to do 3x to the 4th power, because I'm raising this to the 4th power. And that will end up being 3 to the 4th is 81, so this is 81x to the 4th. Now I'm going to do 3x to the 3rd power, so that's 27x to the 3rd. 3x squared, so 9x squared. 3x to the 1st, which will just be 3x. And finally 3x to 108x to the 3rd, y. Then I'm going to do 6 times 9, so that's 54. So this will be plus 54x squared y squared. Oops, running out of room. 4 times 3, so that's 12. This is negative. So minus 12x y to the third, and then finally plus y to the fourth. So this is the expansion of 3x minus y to the fourth power. Okay, moving on. So write the expansion of the expression. So this one I have a power within a power, which shouldn't bother you. You're still going to do it the same way. You're just going to have to make sure that when you write your box, you include that exponent. So I am going to find my coefficients. So here is me writing my coefficients. So my one term is 3. My other term is going to be negative x squared, because I'm going to think of this as plus negative x squared. And I just found my coefficients to be 1, 5. Remember, this second coefficient has to match the power. 10, 10, 5, and 1. So this is going to be 3 to the 5th power, so 243. 3 to the 4th power, which is 81. 3 to the 3rd power, which is 27. 3 squared, which is 90. 3 to the 1st, which is 3. And finally 3 to the 0, which is 1. Now when I go to do this one, it'll be negative x squared raised to the 0 power, which is 1. Then this is negative x squared raised to the 1st, which will be negative x squared. Then negative x squared squared, so that'll be a negative squared is a positive, so this will be a positive x to the 4th. Remember, when you raise a power to a power, you multiply the exponents. Negative x squared to the 3rd, so this will be negative x to the 6th. Negative x squared to the, whoopsie, I wrote that wrong. Negative x squared to the 4th, so it's going to be positive, and so it's going to be positive x to the 8th. And then finally, negative x squared to the 5th, which will be a negative x to the 10th. Now when I do this, I'm going to multiply my coefficients. So my coefficients are going to be 1, 243, and 1. So that's 243. No variable, just 243. Then this will be plus, no, minus, because of this negative sign. And then 5 times 81 will be 405 x squared. Now I'm going to take 10 times 27, so that's 270. So this will be 270 x to the 4th. Now I'm going to multiply, that is just a 9. I don't know what that is. So this will be 10 times 9, so that's 90. So this will be not minus 90 x to the 6th. And then 15 x to the 8th. And finally, negative x to the 10th. So since I have a power being raised inside a power, my exponents, like, you know how I said normally your exponents add up to the power, that whatever this is being raised to, and this is actually a 5, not a 2. That's not going to happen because of this 2. But that is the expansion of 3 minus x squared raised to the 5th power. Boxes are wonderful things. Okay, this is another one, 3x plus 4y. So I'm raising it to the 3rd power, so I only need a couple rows of my Pascal's triangle. So my coefficients are going to be 1, 3, 3, and 1. My first term is going to be 3x. My second term is going to be 4y. So I'm going to have to take into account those coefficients when I raise it to a power. So this is going to be 3x to the 3rd, which is 27x squared. Then I have 3x squared, which is 9x squared. 3x to the 1st, which is just 3x. 3x to the 0, which is just 1. Then this one is going to be 4y to the 0, which is 1. Then 4y to the first, which is 4y. 4y squared, which is 16y squared. Then I'm going to have 4y to the third, which is 64y to the third. So when I multiply 1 times 27 times 1, and that should be the third, I'm going to have 27x to the third. Now when I add 3 times 9 times 4, it's 108, I think. I'm going to have 108x squared y. Now when I multiply my coefficients, I'm going to have 3 times 3, which is 9, times 16. I'm going to get 144xy squared. And then when I multiply 1 times 1 times 64, I'm going to have 64y to the third. I have no faith in myself. Oh yeah, I'm 108. I'm good. And then here, I'm going to rewrite this as 3x plus 4y. That's a 4y raised to the third power. And that's what that's equal to. That's the expansion. So neatness counts. I guess you... So this one wants me to find the fifth term of a plus 2b raised to the seventh power. So hard way is I find the whole expansion. I honestly don't want to do that. So the fifth term, if I go back to this, remember my first term was that combination 7, 0. Do you remember that? That was my first term. So then when I want to do my fifth term, this was the first term. So following that pattern, it's going to be a combination 7, choose 4, because I want the fifth term. So this is always one less than the number of term that you're on. So to find that coefficient, I am going to do 7 factorial over 4 factorial, and then 7 minus 4 is 3 factorial. So this is 7 times 6 times 5 times 4 factorial over 4 factorial, and then 3 times 2 times 1. So the 4 factorials will simplify, the 3 and the 2 and the 6 will simplify. So my coefficient is 35, so I'm going to have 35. Then to find the fifth term, I am going to, that means that this second term is going to be raised to the 1 less power. So this 2b is going to be raised to the 4th power. And then the a is going to be raised to the power that makes the 4, whatever I add 4 to get 7, which is going to be 3, which is going to be these numbers down here, FYI. So, but it has to be in this order. This 2b has to be raised to the 4th power, and the a has to be the 3rd. And so when I do this, I'm going to take 35, a to the 3rd, and then 2b to the 4th, so 2, 4, 8, 16, so this will be 16b to the 4th. Then I'm going to have to multiply 35 times 16. I'm going to do that. I get 560, a to the 3rd, b to the 4th. Okay, the next one's asking me to find the coefficient of the a to the 5th, b to the 3rd term, and the expansion of that. So this one's kind of, I think, easier because they're telling me that the a is to the 5th power, which means that this 2a has to be raised to the 5th power. And the b is raised to the 3rd, so this 3b also has to be raised to the 3rd power. Notice the 5 plus the 3 is equal to 8. Now I have to find that coefficient in front of the whole thing, so I have to figure out my combination. Well, this is 8, and then I need to figure out what my coefficient is. Well, I could put a lot of heart and soul into this, but notice that these here, when I do this 3 and the 4, those are the numbers that match here. And it doesn't matter if I do 4 factorial times 3 factorial or 3 factorial times 4 factorial. It doesn't matter. So it doesn't matter if I put the 5 here or the 3 here. It does not matter. So I'm just going to go ahead and put the 5 factorial here, or the 5 there, and then I'm going to do that combination. So this one, you don't even really need to know what term you're on. You just need to know what numbers to put, because this one is so much easier, in my opinion. So when I do this, this will be 8 factorial. Oh my, hold on. So I'm going to do 8 factorial over 5 factorial, and then 8 minus 5 is 3 factorial. So that, again, doesn't matter. Doesn't matter which one. So I do that. Blech, words backwards. Okay. So I'm going to have 8 times 7 times 6 times 5 factorial over 5 factorial, and then 3 times 2 times 1. The 5 will simplify, the 3 and the 2 and the 6 will simplify, so the 8 times 7 is 56. So I'm going to have 56. This 2 to the 5th is, so I'm going to have 56 up here. I'm going to have 56 times 2 to the 5th is 32, a to the 5th, times 3 to the 3rd is 27, b to the 3rd. And then I'm going to multiply the coefficients, the numbers, the 56 times the 32 times the 27. And when I do that, I get 48384. So 48,384, a to the 5th, b to the 3rd. This question is just asking me to find the coefficient. So technically, this 48,384. And there's your homework. I hope this video helps, and I'll see you next time.